Here we go. F of x plus h, well, that says, this is 1 over x squared, so x squared. So I pull out the x and I replace it by x plus h. And I'm not going to multiply that out. It is not in my best interest to do so. F of x is just 1 over x squared. F of x plus h minus f of x is 1 over x plus h squared minus 1 over x squared. So now, eventually the goal is, there's that h. And if I let h equal 0 at this point, I'm going to have x squared minus x squared, which is 0, which makes no sense. So, as I look at this, the key to this, because I've got a fraction, means common denominator. You're going to be pulling from your algebra all over the place. Common denominator is just the product of these two. So I multiply this guy by x squared over x squared, and this one by x plus h squared over x plus h squared. So now I'm going to take the lazy way out over the LCD, because my focus is going to be the numerator temporarily, which happens to be a product of these two. So there's your LCD. You're going to have x squared subtract x plus h squared, which turns to x squared subtract x plus h squared is x squared plus 2xh plus h squared. We folded that out earlier over the LCD. And I always write the LCD in. Why? Because we get so caught up in simplifying the numerator, we forget we had a denominator. You say, oh yeah, so much work, and then we forgot the denominator was there, because that's the key to the whole thing. So this then becomes x squared minus 2xh minus h squared all over the LCD. Now if you notice, everything goes except terms in the numerator that have h's. So now I take what I got in step 3 over the LCD, which is x squared times x plus h squared. That gets divided by h. Which is h over 1. Now what do I get to do? It's a complex fraction. So what do you do with a complex fraction? Begins with an I. N, V, N, E, R, T, invert, and multiply. So that this becomes negative 2xh minus h squared over x squared times x plus h squared times 1 over h. So you notice that there is a greatest common factor of h in that numerator. So what happens to the h's? They reduce out. So what you're left with is minus 2x minus h over x squared times x plus h squared. Now if I set h equal to 0, I'd have 2x in the denominator, 2x in the numerator, right? H equal to 0, then I'd have x squared times x squared, or x to the 4th. I would no longer be dividing by 0. And that would be the slope of the line between any 2 points on 1 over x squared.